Hello, everyone. I'm Kellan Heavican with Brownfield Ag News. Joining me today is Terry Griffin with Kansas State University. Terry, thanks for joining us here this afternoon. I always find this conversation really interesting about geomagnetic storms. I think it's a unique phenomenon. Tell me, in your career, tell me about how you kind of look at the situation that's developing over the U.S. here this week.
I've been evaluating GPS since the mid 90s for my academic research, for my master's degree and my PhD. And, since GPS has been used on farms, we haven't had very many GPS outages or signal degradations. And so these are relatively new. But that's kind of the funny part. Since GPS became available for agricultural purposes in the late 1990s, we've had very few, if any, solar activity that would affect GPS. There were many events that happened in the 1960s, 1970s, before GPS was developed, that would have been a major geomagnetic storm. But those were before we had GPS. And it's just today, last year, this year, it's the first time we've had GPS and solar activity strong enough to influence the ionosphere.
Well, let's take a step back maybe before we talk about how the activity we're seeing may impact GPS systems this week. Tell me what is happening with the sun and the magnetic activity and solar flare. Give us a picture of what's going on right now.
So the sun follows a very regular cycle. So every 11 years, the number of sunspots that can be viewed on the surface of the sun facing the earth peaks. And the opposite's true too. Every 11 years, the number of sunspots hit a minimum too. Maybe they go to zero for a while. Right now, we just recently passed solar maximum about 12 months ago. November of last year, we believe was solar maximum of solar cycle number 25. And when we say solar maximum, what we refer to is the number of sunspots that are visible on the surface. Sunspots themselves are not directly affecting Earth, but when sunspots collide, like they did in May of 2024, when active regions, sunspots, merged together, increase the activity. It causes some solar flares, the brightening of the solar surface that can be visible from Earth. As well as ejecting material into outer space, were referred to as coronal mass ejections. CME is the acronym that we hear most of the time. And last May, we had several CMEs that were launched from the sun on May 7, May 8th. It took a few days to get here. It's moving really fast, but not at the speed of light. And it arrived here on May 10th, May 11th. We had some lingering issues on May 12th. By the way, if we look at the sun through, the proper telescopes, it takes 8 minutes and 20 seconds for light to move from the sun to the Earth. That's light speed. Coronal mass ejections sometimes take a day and a half, 2 days, or maybe a little bit longer to get to us. Today, we received a geomagnetic storm prediction watch from NOAA, Space Weather Prediction Center. So NOAA is our familiar National Oceanic and Atmospheric Administration, the National Weather Service. Today at 11:13 a.m. Central Time, we received an email alert, and you can receive these too if you go to their website and sign up for them. The Space Weather Prediction Center said, hey, we're predicting tomorrow, on Wednesday, November 12th, a solar storm, geomagnetic storm category G4, which is pretty severe. It's the second highest storm rating. Last year on May 10th, we had a G5, but it was barely a G5. Tomorrow, the prediction, the forecast is for G4 due to a X-class flare that occurred at the sun and with associated CME heading towards us.
So that then impacts the GPS systems that farmers use across the U.S. What type of impacts do you expect this to have over tomorrow, on Wednesday, Thursday, so forth and so on?
So if you look at the email that came in from Space Weather Prediction Center, they do list GPS as being potentially affected. They said satellite navigation can be degraded or inoperable for several hours. They also list radio, high frequency radio propagation. You know, the amateur ham radio operators are very sensitive to these things. And so for November 12th, you know, I would look at the USDA statistics to see how far along Nebraska and Kansas farmers are with harvesting corn and planting wheat. But as you know, the government shutdown has stopped those for the last 5, maybe 6 weeks now. But if you look at a 5-year average for corn harvest in Kansas, we would be at 94% this week. Nebraska would be 87% completed corn harvest, and North Dakota, the 5-year average would be 72% corn harvest. And when we think about harvesting corn, harvesting soybeans, GPS guidance is not as important as it is for planting of those crops, to make sure everything's in straight rows and avoid the wide and narrow middles. But I think this is a time that we need to start talking about data. You know, so if people who follow my research and extension program know that I spend a lot of time thinking about farm data. And one of the things I think about is how do we use yield monitors? And one of the big ways, one of the most profitable ways of using yield monitors and GPS on farms is to conduct on-farm experiments under the farmer's management, under their soils and environment. And we have good information that would suggest that, you know, more than a fourth of planted acres in the upper Midwest, where we are right now, have collected data with yield monitors to do on-farm experiments. So the experiment goes in maybe for tillage or varieties or some applied crop protection chemicals or fertility in the spring, the summer, and we're waiting to collect that data here in November. You know, there's a lot of effort goes into doing an on-farm experiment, and if we lose the ability to georeference that yield data, those on-farm experiments will be largely, the value will be largely negated because we're not able to analyze those experiments. That's a huge deal that, in my mind. You know, in May 2024, we had problems putting seed in the ground, which is an operational problem. In November, you know, we're planting winter wheat, but winter wheat may be a little bit less susceptible to, you know, wide and narrow middles because, you know, tillers and whatnot. But the on-farm experiments, those are of interest to me right now. And if I had a recommendation to farmers, if you're planning on harvesting those experiments this week, you may want to wait until you make sure that we have good GPS in order to be able to georeference that yield data.
How long do you think that the potential disruption to the GPS signals will last this week?
So that's a good question. Forecasting, you may not believe this, but we're not as good at predicting forecasting space weather as we are terrestrial weather. So we really don't know for sure because we haven't had too much experience at this. But I can say that if you look at the Space Weather Prediction Center email, they're predicting a G4 for tomorrow on November 12th, a G3, which is a strong geomagnetic storm, on November 13th, and a G1, which is minor, on November 14th. We've had several days in the last couple of years that would have a quick, sporadic, one-time, 1 3-hour event of a KP, is the planetary index for geomagnetic disturbances, is spiked and then it went away. They're calling for 3 days in a row of G1 or higher, 2 days in a row of G3 or G4. So we're having a prolonged days back to back of geomagnetic disturbances. So it could be, you know, a few hours, 2, 3, 4 hours, or it could be longer. And it kind of depends on how susceptible the GPS hardware is. So even with minor geomagnetic disturbances, an older base station. If you have new tractors, new receivers on the tractors, but an older RTK base station, that's going to be the weak link. Okay, and so the newer hardware will have less susceptibility to these outages. But that's not a universally true statement either, because if we do have a severe outage and the signals from GPS arriving at the Earth are nanoseconds off, well, the GPS may have a hard time of making any sort of lock at all. It wouldn't necessarily be 4 inches off or 3 feet off or 10 feet off. There may be no positioning locked at all.
Terry, last question I've got for you as we think about, I know we talked about this in the spring of 2025, and we said, well, it could last into 2026. How long might this stick around, these occurrences?
So if you look at those cycles I was referring to, they're 11 years from peak to peak. We're in a downhill slide right now, but that doesn't mean we're out of the woodwork, because many of the more severe geomagnetic disturbances happen on that downhill slide. So looking at the timing, we would think that spring of 2026, we would definitely still be in the danger zone. This time next year, we will probably be a lot safer position, and it's going to be quiet for several years. And then, in 5, 6, 7 years, it's going to ramp back up again, and we're going to experience this again unless the industry is able to replace GPS with a less susceptible alternative. I hear rumors of different technologies on the horizon, but they probably may or may not be available in the next decade. And a decade is sort of an eternity when it comes to technology. But if you think about GPS, the first satellites went up in 1978. So this is not new technology. It's been around for quite some time, and we're still increasing our reliance upon that technology that is 50 years old.
Terry, those are my questions. Anything else that you want to add?
I do want everybody to subscribe to the Space Weather Prediction Center forecast. Every time there is a watch or a warning, you'll get an email. And their website is spaceweather.gov, and you can kind of read all about the physics and the astronomy part of space weather. There's really good information on that website, and I encourage people, if you're having problems, check that out. And if it suggests that there may be something that's space weather related, there's nothing that your business partners and your service providers can do about it. It's a global issue, and that would be the first place I would look.
Well, Terry, I appreciate the time. Thanks for joining us.
Good to see you again.